Okay, so we want to create the modulating oscillator. So it's this guy over here, right? We want to be able to control the fixed frequency, which is related to the carrier frequency and also to the harmonicity ratio. And this frequency is then related to the amplitude variation of the modulating oscillator, which is also dependent on the modulation index. So we'll try to break this graph down into some smaller steps and then implement it in CMajor. So we need to take care of the modulator phase. So we will just call this modulator phase. We also need some more input events. We need, I had a new shortcut. I'll just show you, which is really cool. So this cursor word right and left select, this is a new shortcut that I just found in VS Code. So what I can do, I'm here at C, and then I Control Alt Shift W, and then I select where the camel case is. So that's pretty cool. So I can call this harmonicity ratio. I could also just have deleted the entire word because I didn't actually need to use that shortcut. But anyway, index, and then I need some more smoothing parameters here. So here I can use my shortcut. That's the other way. So I can say harmonicity ratio, thank you, and modulation index. Cool. And I need some, I will extract this calculation into just a variable called time step. And then I'll just do this because we only need to calculate it once. And that looks right there, there. Oh. We can set time step here. And then I will make a new event. And actually we can make this shorter. So it's just one line like this. And okay, so first we have the calculation of the carrier phase from the previous iteration before the advance. Then I want to get the current value of the smooth parameters, and I want to increment them. So let's make some variables for the carrier frequency, the harmonicity ratio, and the mod index from the smooth values. Remember, the let is not like the let keyword in JavaScript. It is a constant, but with an inferred data type. So you don't need to write float or int or something. It figures this out itself, but it is a constant. The variable, I don't like with inferred data type would be called a var. So var is not a constant, but let is. You can read more about let, var, and other data types in the CMajor documentation in the section about variables and constants. So let's call it C freak. And is the carrier frequency get next? Thank you, Copilot. And mod like this. We want to calculate the mod frequency. So that's the carrier frequency multiplied with the harmonicity ratio. So we say let mod frequency C freq the harmonicity ratio. Right? Then we can also just calculate a variable we need a few times called maybe delta increment. And that is processor.period times 2 pi. Now we want to calculate the modulator phase delta, mod phase delta, and that is the float of the mod frequency times the delta increment, right? So you remember when we calculated the carrier delta, it's like the difference between what the phase was and what the phase is going to be, right? And that is, of course, dependent on the frequency of the modulator, but the rest of the calculation is like the time for this sample or this frame times 2 pi, so we get it into radians. Then we set the modulator phase, and that is the same as down here. Then we want to calculate the amplitude. So that's the modulator frequency multiplied with the modulation index. Mod amplitude scalar. So that's the mod frequency multiplied with the modulator index. And then we calculate the output of the modulator, which is the value that we're going to add and subtract from the static carrier frequency. So let's call that mod value, which is the sine of the modulator phase multiplied with the amplitude scalar. So that's this value here. And then we can make a new, let's say, carrier value. So that's the carrier frequency, and then we add the mod value to it, right? So if there's a fixed carrier frequency of 100 hertz and the mod value goes from -10 to 10, then the resulting carrier value will be in the range of 90 to 110, right? Because it's 100 minus 10 or 100 plus 10. And then we use the carrier value to set instead of this. And then we use the delta increment, which we already calculated here, here. And then we, of course, need to update our connections because we would like we would need to make some more inputs. So let's call this harmonicity ratio, and let's do that again here. And maybe let's just say 0, so there's nothing, and then maybe just 4. And it's not in hertz. And we can say a modulation index, and that's there. And let's just say 0 to 4 maybe. Okay. And then let's make the connections here. And we say thank you, Copilot. And maybe let's make the output multiplier up here. So we say, so it's a bit more quiet. But it's nice to have it outside of the oscillator because it's not actually a inherent thing of the oscillator. It should output the maximum value, right? So we don't forget it down here. So if Copilot helped me enough, then there was no spelling errors. Sounds pretty cool. Yeah, nice. Okay, so I think the next video should be about MIDI input, maybe polyphony, and then I want to make maybe some panning and an amplitude envelope or something like this. Yeah, stay tuned.